Okay, so thank you very much for that introduction. Thank you very much for having me. I've been working with Potato Mop-Top Virus for approximately 6 years. And today I will just want to talk to you a little bit about some background information about Potato Mop-Top, and then really speak to some of the things that have been going on here in the United States, and some research that we have been doing in my lab that I hope is pertinent to your situation there. And so, as Rose mentioned, we have had Potato Mop-Top PMTV in the U.S. for about 20 years. Really, we know that it's present in most potato growing regions around the world. And I just included a couple of instances here, or examples of published research that just looked at, in the US and Canada, looked at seed lots that were tested. And that first one, it was tested by a Canadian group about 20 years ago now, where they found a little bit more than 4% of seed lots. Over 3,000 seed lots tested were positive for PMTV. More recently, some of my colleagues in Washington State have tested seed lots over from 2016 to 2022, and 200 to 300 seed lots per year, and really have found that in that same range, right, approximately 2 to 5.5% over that time. And it really, there's some variability certainly here in that graph on the, excuse me, let me get my pointer out here. In the graph here down in the lower right, you have a little bit of an increase, but really it looks like it's stabilized, which is somewhat interesting to me, that we don't see sharp increases. So we don't see foliar symptoms of Potato Mop-Top virus very often, in fact, quite rarely. The symptoms here represented in this picture are relatively typical of PMTV foliar symptoms. Some stunting, mottling, chevrons and yellow blotches or rings that you can see in this picture. These only occur from seed-borne infections. You don't get these foliar symptoms from infections that occur during the growing season, or those secondary infections. They occur on the lower leaves typically, and those lower leaves typically senesce and drop. And so it's really, those symptoms don't stay on the plant for very long. It's very rare to find these in the field. Certainly, these symptoms can be confused with other viruses, in particular alfalfa mosaic virus. I actually, earlier this season, thought that I had found a seed-borne PMTV plant, and indeed, those leaves came back positive for alfalfa mosaic virus, but certainly very similar, and some overlap in the symptoms that we see between those two viruses. Tuber symptoms are what are most important, certainly. I don't think that's news to anyone. PMTV typically does not reduce yield. There have been some reports of yield reductions greater than 20 or up to 40%, but that's difficult to separate from the yield losses that occur from powdery scab, right? The vector. And so typically, we don't, at least under our growing conditions, see a yield loss that we could attribute directly to PMTV. Really, what the loss is here are those internal tuber necrosis, the spots, the arcs, the rings. And typically what you see online are symptoms more like this in the upper right-hand corner, right? Really pretty severe, and those sort of concentric necrotic rings. Down in the lower right are a somewhat milder symptom. Again, you have those arcs or sort of rings happening here, but you don't have that concentric sort of situation. But over in on the left-hand side picture, this tuber has been sliced in about 1 centimeter slices. And so this picture, these 3 slices are of the same tuber, and really there are some small necrotic flecks, and maybe some start of a ring, but really this could be attributed to many other things. And in any of these cases, really looking at a situation where this is going to reduce tuber quality overall, regardless of the type of symptom. We also see situations where very rarely, but on occasion, some cultivars show external symptoms. And some of those, again, are those concentric rings. They kind of mirror what you see inside of the tuber. But in the lower left-hand side here, really, this is these tubers, in all of the pictures I've shown here, these tubers all tested positive for PMTV. So we have confirmed that, even this light ring, and over here, you really can just barely see that kind of raised area and those rings. And again, this is not a common symptom that we see. Typically, we just see the internal symptoms of PMTV, but certainly in some cases we see these external rings. This graphic is really just to point out that a lot of times PMTV can be confused with several other virus symptoms, and as well as zebra chip. And so the necrotic strains of PVY, again, you kind of get those raised lesions in the upper right-hand corner there. The raised lesions that are characteristic of PVY, the rings are a little heavier and more distinct than PMTV, but certainly there can be overlap in those external symptoms. And then to the bottom right, tomato spotted wilt virus and tobacco rattle virus, which the internal symptoms are very, very similar to PMTV. And I don't trust my eye to distinguish between the two of them. For the most case, we test everything that has any kind of internal and external symptom that are kind of in this overlapping realm. I also show zebra chip just as an example of sort of that. This could be an overlapping symptom with potato mop-top virus, and certainly in that situation where you just have those slight necrotic flecks, it can be an overlapping symptom. But we know that, of course, when zebra chip is fried, we get much darker looking chips. So, I believe everyone is relatively familiar with powdery scab, but we can't really talk about potato mop-top virus without talking about its vector, powdery scab. And so really, anywhere that PMTV wants to go or can be found, it has to be associated with the powdery scab pathogen Spongospora subterranea. And so just showing, from the lower left, those tuber symptoms of powdery scab and the sporosauri or the spore ball, those resting spores are released and the virus is carried with these resting spores and with these zoospores to, reinfect during the season. And those root hairs, that blue is, the plasmodia of Spongospora subterranea. And so even though we don't get severe symptoms of root galls or severe symptoms or any symptoms of root galls or tuber pustules at all, we indeed may have a situation where we have the plasmodia present in the root hairs, and you don't see it to the naked eye, but indeed you have powdery scab, and that is in an area where potato mop-top virus can kind of go undetected, right? You look and go, why I don't have powdery scab, how could I have PMTV? Well, indeed you may have both in some situations. So disease management is not simple for these pathogens. Of course, we wouldn't be talking about it if it was. It wouldn't be a topic of conversation. So the disease management is limited for both pathogens. Certainly, powdery scab, and I put PMTV in parentheses there because, as I said, anywhere we have PMTV, we of course have to have powdery scab. And so those infections are favored by cool, moist soils. Cultivars vary in their sensitivity to both powdery scab and PMTV induced tuber necrosis. And I specifically point out the PMTV induced tuber necrosis because we know also that we can have PMTV positive tubers that don't show any tuber necrosis symptoms. And then the incidence and severity of the tuber necrosis can increase during our time in storage. And that's one area that, growers can have some effect on the management. And really one of the most important things to hit on is the idea that the powdery scab pathogens, Fungospora subterranea, and PMTV are spread with soil and with seed tubers. And my goal is to go through each of these and try to just indicate the importance and maybe the action points of each of these areas. So we know that, as I said, cool, moist soils, and in particular during tuberization, increases disease severity, and that's both powdery scab and PMTV. But reducing soil moisture during tuberization is not a simple thing, right? Suboptimal moisture can increase common scab. Typically, that's more important earlier in the growing season, but really there's a challenge to balance irrigation for powdery scab with the management, powdery scab and PMTV management with our yield goals. One thing that we can look at also is kind of avoiding planting in poorly drained soils. Again, this is a situation where what's favorable for powdery scab is also favorable for PMTV. So these data came from a growth chamber experiment that was done about 10 years ago, and showing basically that what they did under the growth chamber conditions was they maintained wet conditions throughout, greater than 90% soil moisture, or dry early and wet late, and early and wet were separated by 50 days before and after planting, and then dry is around 60% soil capacity, and as we move through these from left to right, wet throughout obviously has higher disease incidence of both powdery scab and of PMTV. And we go to dry early, there is a reduction, but it's not significantly different, kind of pointing to that idea that the dry during tuberization is the more important point, where you go to the third set of bars, and there now becomes a significant difference from the wet throughout, and then certainly dry throughout. Now, the difficulty here is that under field conditions, this is much harder to manage. And field trials have been conducted that indicate that you can't manage it well enough to be able to actually reduce the severity of powdery scab, and you risk that yield reduction. So certainly this is potentially an area that could be investigated, but there are also negatives on attempting this as a management strategy. There are instances where observations in the field, such as even the difference between the side of the hill that faces the sun and the side of the hill that does not, having differences in severity of powdery scab and PMTV. So it can be very slight moisture and temperature changes that can affect both of these pathogens. So cultivars are another area where we can really have an effect on the severity, the management of PMTV. Cultivars vary in their sensitivity. Again, as I mentioned, to PMTV tuber necrosis, no known cultivars at least, are completely resistant to infection by either of these pathogens. Where we're looking at differences are among the expression of that tuber necrosis. And so certainly tubers may be infected, but they may not be displaying that tuber necrosis. And that's where we see some differences. So the recommendation there is to plant cultivars insensitive to PMTV, that tuber necrosis phase. While this might reduce economic losses in the field, it is extremely important to remember that this does not limit the buildup of the pathogen in the soil. And that is key to when you're going back to those fields, to when you're going to plant again. You're going to be increasing the inoculum, even though these cultivars do not display the tuber necrosis symptoms, or the powdery scab symptoms for that matter. It's extremely important to remember that. So this is some data that were published a few years ago out of North Dakota State. And here they looked at, I believe it's a total of about 60 some cultivars. And what it's broken down into is these listed here are the non-russet cultivars that are insensitive or have less than 5% PMTV tuber necrosis incidence. And I highlighted Desiree there because I believe that's a cultivar that you're familiar with there, and I'm uncertain about the rest of these. But I think the main point here is that out of these 39 cultivars of the non-russet type, 21 of them were found to have that low incidence of tuber necrosis. Here we break it down, or the authors broke it down into moderate in that 5 to 10% range, and the moderately sensitive, and that meaning sensitivity to the tuber necrosis, and then the sensitive, and in 6 cultivars in each of those ranges. When we look at the russet cultivars, again, out of 24 cultivars that were russet skinned, almost all of them fell into that less than 5% disease severity, and that's the tuber necrosis severity. And so we know that these data and other data have pointed out that russet cultivars are less sensitive to that tuber necrosis, and but it's certainly, we also know that we see it relatively often, even in the russet cultivar. So it doesn't mean, I can plant a russet cultivar and I'm going to be free from it. It just really means that compared to maybe another cultivar, you might be better off with a cultivar in the russet category. So the next sort of area that we can look at is during storage. And so one thing that we know is that these pathogens do not necessarily spread during storage. You don't get new infections. But what does happen is that tuber necrosis will increase in both severity and incidence during the time that potatoes are in storage. And so one of the action areas here that we can actually take is if we know where there's a situation where we have PMTV, either in that field, or we know that the crop that you've harvested from there is infected with PMTV, we can try to ship those sooner so that tuber necrosis does not have time to increase. There are some data, very little data on kind of storage management of PMTV or of the tuber necrosis phase. There are some indications that maybe cooler temperatures, but again, that's kind of similar to the watering situation. It's often not really possible under certainly processing conditions. The product color is not going to commonly do well under those colder conditions. So these are some data that were generated again, about a decade ago. On the left-hand side was 1 year, 2015. On the right-hand side, 2016. A little bit different storage regimes or when those tubers were evaluated, but a similar kind of story where relatively early in storage versus relatively late in storage. And then across the bottom, we look at the different types of market classes and the number of cultivars of each market class that were evaluated in parentheses there. So certainly in 2015, we had lower incidence of tuber necrosis. That might be somewhat because they were evaluated sooner, or just the field conditions in that year that these crops were grown. And then, really a moderate increase about 100 days later in storage. Certainly some cultivars or some types were much higher in the increase than others, but in all cases, certainly an increase in tuber necrosis. The situation in 2016 was relatively similar, but really obviously you can see that these increases are much larger. From the green, which is that, about a couple of months in storage versus about 100 days later, how these tubers were evaluated. Now, important to note that This tuber evaluation was conducted by slicing tubers and looking for any discoloration in those tuber slices. These were not tested for the presence of virus. These are truly just looking at symptoms of the presence or symptoms of the virus. So as we move on here, one of the main things that is important, and you know, we're familiar with this with powdery scab, but PMTV moves with powdery scab that moves with soil, and so that anytime any soil is moved, then we are also moving powdery scab and potentially PMTV if the powdery scab pathogen is carrying the PMTV. So it's really all about cleaning field equipment. Cleaning field equipment, not only when you're growing your potato crop, but also when you're growing your rotational crop. And then not only equipment that maybe stays on your own farm, but equipment that's coming off-site or equipment that's coming from temporary staff. Certainly, you know, we have limited options of you know, limiting wind-blown soil, but that's an important piece as well as thinking about compost. The powdery scab pathogen can survive through the composting process, and therefore, you know, that can also spread the powdery scab and PMTV. The other piece is that it is spread with seed tubers, of course. So infected seed tubers, as I mentioned, may not display any symptoms of powdery scab or the PMTV tuber necrosis, but indeed might be positive and can spread that into your fields. So plant clean seed into clean soil. We do not currently have a certification standard in the United States. Growers can request that their seed is tested, but it is not a requirement. We have PCR assays available for both the powdery scab pathogen and PMTV, and we test those from both soil and tubers. And I'll just give you here going forward some examples of some of the work that we've done in that area. Excuse me. So this is a large project that we did over the last handful of years. And we've tested over 100 fields in this kind of grid sample. We did it in cooperation with a grower who did it on 2.5 acre grids, over 4,000 soil samples that we tested across 4 farms. And you know, you can see the information that we used there as far as testing these samples is concerned. So this is in farm 1 through 3, we only found powdery scab. We did not find PMTV. So I'm not presenting those data, but here I'm presenting data from a single farm. We tested 37 fields, over 1,000 samples. And as you see here, almost 90% of their fields were positive. And among those samples, it was really relatively widespread. Approximately 74% of those, excuse me, the Spongospora was almost 90%, and the samples were almost 74%. The PMTV, a smaller subset of the positive samples. That graph below really just indicates the amount of PMTV that we found in those Spongospora positive samples. And so we split that out into low, less than 100 sporosauri per gram. And again, this was determined via PCR. And then moderate and high sporosauri per gram. And then the green in the graph indicates those samples that were PMTV negative and those samples that were PMTV positive. You'll note that in the Spongospora low category, we did not find any PMTV positives. And that's something that we see consistently across our testing, our soil testing. And I think that it's probably more of an instance of the sensitivity of the PMTV assay, potentially, that just when we get those low levels of sporosauri, that we're just not able to pick up the virus in those low soil samples. But also, this graph really demonstrates the idea that when you have moderately high Spongospora levels, the amount of PMTV isn't as high. When you have high levels of Spongospora, the number of samples, this is an incident situation, but the number of samples that have PMTV are higher. Now that would lead you to believe that, okay, well, the amount of Spongospora is related to the amount of PMTV. When you look at these crude numbers, that looks like the case, but in reality, it really isn't. This figure really demonstrates that quite well, I think, anyways. So what we have going on here is a Spongospora map overlaid with a PMTV map. And so the Spongospora soil testing sites are denoted by the circles, either the closed circles or the open circles. And the black is that really low level, moving up to the white, the light green, and the darker green circles are the highest level of Spongospora that we found on this farm. And then the levels of PMTV go from kind of those cool colors, the light blue or light green, to those warm colors through red and into that bright yellow that represents the highest level of PMTV. And there are a couple of things here that I think are important to point out. And that is, if we start up here in this upper left-hand corner, you see a situation where we have powdery scab at moderate to high levels with those open and green circles, and we have PMTV. When we go down into this this circle, it's really adjacent here, but the levels of powdery scab are really quite low or moderate, and it's only found in a couple of sites in this field. So what we estimate from these data are that it was likely introduced here and either drug over to this field or windblown over to this field. Again, this is just sort of, our hypothesis. Same situation over here where we have these two hotspots that are, or these two PMTV detections that are at adjacent fields. And that really seems to be kind of the trend overall, where we see this situation where we're moving it. Likely, again, this is just a snapshot. We don't know, specifically what's happening here. We don't know when it was introduced, either of the pathogens. We're just taking one snapshot of the picture. Another thing that I think it's important to point out is that there are some areas with these dark green circles, both here and in here, and even really these light green circles in these fields, is that there are very high levels of the powdery scab pathogen, but there is no PMTV detected in those areas of those, or in those fields. And so certainly, like I said in the previous graph, it appears as though in some instances, the higher level of Spongospora really has a relationship to the higher level of PMTV. But this figure really does show us that that is certainly not always the case. There are instances here where the powdery scab pathogen was introduced at one point, and the PMTV has never been introduced. There's potentially areas here where the two pathogens were maybe co-introduced together. And so these are some of the things that we can kind of think about or hypothesize, but we really don't have the data that are necessary to be able to know if that's the case or not. The second question one of the questions we've had about seed testing is when to seed test. And so right after harvest, do we wait? What happens? And then where on the tuber, and if we think about direct tuber testing or dormant tuber testing, where on that tuber will we be most likely to find the virus if it's there? And so we conducted a trial from field-grown tubers over 2 years. We tested 11 cultivars. We started testing for PMTV in these cultivars 1 month after harvest. But part of this and part of understanding the data, what the data represent, is that we tested a new set of cultivars each month. It wasn't the same cultivars that were tested over time. So there is some variability introduced there. But that has to be balanced with the idea that, you really, we took a biopsy punch from the stem end and a biopsy punch from the bud end, and we were afraid if we kept taking too many punches from each of those ends, we would not necessarily have directly relatable results either. those tubers were stored for the duration, and we then developed this kind of these data that represent our questions, the attempt to answer our questions. And so these data are just represent from 1 year. We did not repeat the comparison between the bud end and the stem end. We did not repeat that both years. But if we start over on the left-hand side, we have a situation where we have very similar results with the detection of the virus in both the bud end and the stem end. But about half of the time, we're actually detecting it in both the bud and the stem end. And if we move over to this upper graph, we're looking at here the across time. So in each month, we have again that, you know, both ends, and then separately are we detecting it in the bud and the stem end. And it appears as though, you know, over time, the bud end kind of increases and then it levels off with those gray bars, similar to kind of what we're detecting in both. But it appears as though from these data, and again, this is a single year, but it kind of, the virus tends to increase a little bit towards the end. I show the figure on the bottom as far as cultivars are concerned, because we didn't seem to have a change in the cultivar, the difference between the bud and the stem end on cultivar, except one cultivar, where we did have quite a large difference and a significant difference between the bud and the stem end. The rest are very, very similar this is across the time. These data represent both years of the study, and both 2020 and 2021. And again, we're looking at across time. And this is the combination of both the bud and the stem end, all of the data, not just one or the other in that comparison. And what we found in 2020 with the gray bars is that we had an increase from the first month to the third month. And this is, you know, 1 month after harvest. And then it seemed to level off really nicely. And we thought, okay, these are really, really nice data. Of course, sometimes when you repeat things, it doesn't always come up as cleanly as you'd like, but we do see that consistent increase to the third month. And then we have a little bit of noise here with the following months. Again, you know, we were testing different tubers across that time. So that's certainly why some of the variability is here. But really consistent in both years is that increase from 1 to 3 years, with month 1 being significantly different in both cases than what month 2. Again, I show the cultivar data. And some of these, probably most of these cultivars you don't deal with, but I think there's some importance here where we see some differences in the year. And so these are field generated tubers. And in 1 year, we've had quite low, and in the next year, relatively high levels of the virus. And really, this speaks to the idea that even though these trials were replicated, there's variability of this pathogen in the soil, and that not only across a single field, but also across years. And so it's important to kind of keep that in mind as you're looking at a situation where you may have screened in a single space or time where something looks pretty good. Well, you know, you get to the next year's data, and that might not carry through. So our conclusions from this, that it appears to be better to wait up to 3 months to testing seed. That increase, again, we got a significant increase in both years. From the first month after harvest to the third month, we detected significantly more virus in those tubers. And that, again, those data are across all 11 of those cultivars, and pretty consistent across all 11 of those cultivars. We would recommend to test both the stem and bud. We know that we're missing if we just test one. And it also there's been some work and looking at testing bud and stem and an eye or two, just to and those get just bulked into a single sample. But taking those samples is important in that the virus might not be equally distributed across a tuber. We know that, Bannock russet was infected at very low levels both years. And so that consistency is promising. Again, it's not resistant, certainly. And this is measuring these data. We were actually testing for the virus. These data are not just tuber necrosis symptoms. This is testing via PCR for the virus presence. There's variability in some cultivars, and I've talked about that. This is commonly observed in field screening with any of our soil-borne pathogens, certainly. But because Spongospora and then, of course, PMTV are so relied on the soil moisture, that it's really important that we have replicated and repeated experiments when we're looking at kind of evaluating cultivars for any sort of resistance or insensitivity. So in summary, we know PMTV moves with its vector. Do not spread infested soil. Anytime we're moving soil that is infested with Spongospora and maybe carrying PMTV, that's where we're moving it. And certainly I think that those maps represent that quite well. It can move, the soil on or in infected seed tubers, thinking about when you get seed, that soil that's adhering to it also might be a carrier as well as the seed itself, anything that spreads soil. That management of field moisture is a potential, but again, as I talked about earlier, there are some challenges with that as a management practice in a commercial setting, certainly. Again, that idea of planting cultivars insensitive to the tuber necrosis can kind of reduce that economic loss, but you may still be carrying the virus. And so it's really important that you keep that in mind, that you may still be carrying the virus and you indeed may be spreading it and building it up in the soil. And then really that limiting storage duration. And as I showed those data, and there are other similar data, I just showed one instance of it as an illustration. That certainly is important. This is the team that has worked on this over the past years. This is those individuals that have worked in my group on PMTV specifically, that either have or continue to do so. A fantastic group of people to certainly to work with, and they've produced some fantastic data. And then part of this, those data were generated, those data that were generated from my project were a result of our potato virus initiative in the United States. And that's a federally funded project.